Hi everyone, welcome to Winter Sportswear Wednesday. And today we are going to be looking at applications of completing the square. Maximums and minimums mean those points of the parabola that are either a maximum or a minimum. That is where you find the optimum value of a parabola. Oh my goodness, my XY plane there is a little bit tilted, isn't it? So here, yeah, there we go. So if I have my axes, my coordinate axes here, here's my X, here's my Y, we're going to be seeing some situations where real world data or real world structures even might be shaped like parabolas. And we might be interested to know, for example, what's the biggest truck that I could drive underneath this parabola? Like what's the maximum height of that bridge? And to do that, we could find that by completing the square if we had the equation of that bridge. So let's take a look. Here's a situation where we have food in the refrigerator and we have a function here. We can call it, this is n of t, but really this has been borrowed from grade 11 stuff. This is y. Y equals 20 times t squared minus 20t plus 120. Okay, here's an equation. What shape is that equation?
Don't know.
A square.
Triangle.
Rectangle.
You guys are so mean.
So
You're bullying me.
Octagon.
We've talked about this so
A
much.
a
square.
cylinder.
Very good, my star student. You notice that we have our variable raised to the power 2. And whenever we have a variable raised to the power 2, we will have a quadratic. So yes, that's right. This is a quadratic. Very good, star student. Now, carrying on. Time starts at -2 and goes to 14. So we have here some kind of equation that's going to represent the amount of bacteria inside the food. And we want to know, when will the bacteria be minimal? Will this parabola have a maximum or a minimum?
I forget the name.
Okay, so if the parabola opens upwards, it will have a minimum value. If the parabola opens downwards, it will have a maximum value.
Oh,
Hannah?
a minimum.
Yeah, this is a positive number here. So my A is positive. So this parabola opens upwards. In fact, it's quite slopey, has an A of 20. So there's going to be some point where the bacteria is the lowest, and that's where you'd want to eat this food. And it's going to be somewhere over there. So, boop. 2 ways we can solve this problem. It says, at what temperature will the number of bacteria be minimal? So one of the ways is to find the vertex, and that will tell us what temperature we should put for our refrigerator, and that will be the lowest possible amount of bacteria that we'll get. Okay? Because T is temperature here. So we can set the temperature anywhere from -2 to +14. Now you could go ahead and you could test all the values with some real food in your fridge, or if you had this equation, why wouldn't you just do the math? So if we're going to complete the square, we're going to take 20 t squared plus, minus, write down the equation right, Mr. Jennings, minus 20t plus 120. And I'm going to complete the square. That'll tell me the vertex. So my first step is I factor out this A from the A and the B, but not the C. I leave the C alone. So that would be 20 multiplied by t squared minus t. So that's just 20 divided out of both of these terms. This is a minus, so that's a minus, plus 120. Okay. Now I notice here my B value is -1. So I'm going to take -1 over 2 and square it. That's going to give me 1 over 4. Because -1 times -1 over 2 times -1 over 2, you multiply top times top. -1 times -1 is 1. Bottom times bottom. 2 times 2 is 4. Aren't fractions lovely? Aren't they wonderful to work with? So I have 1/4 there as my Jerry Maguire number. So I'm going to rewrite this as this is equal to this. This is equal to 20 multiplied by t squared minus t plus 1/4 minus 1/4 end bracket plus 120. It's all the same. Yeah. Now this here is a perfect square trinomial. So let's write that as a perfect square trinomial. You look like the Christmas ham. And now here, 20 times t minus 1/4. Sorry, 1/2. I get that minus 1/2 over here, squared. That's all this stuff. And now I'm going to take that 20 number and multiply this number so that it can come out of the brackets. 20 times negative 1/4, negative 5. A negative quarter of 20, well, a quarter of 20 would be 5. So a negative quarter of 20 is negative 5. So we have a negative 5 popping out of the bracket, being ready to be incorporated with that 120. So we have this as minus 5 plus 120. And then final answer equals 20 times t minus 1/2 squared plus 115. Okay, here's my vertex. Therefore, the vertex, I'll scroll this up a little bit so you can see all the work. Therefore, the vertex is at the point 1/2. It's positive 1/2 because this is a sign flipper, and 115. So if t was measuring temperature, and we just found that the vertex of this function, of this equation, happens at the t value of 1/2, that's the answer we're looking for. What temperature should we set the refrigerator at? Positive 1/2 of a degree, just above freezing, and we will get the lowest possible concentration of bacteria. That's method 1. Method 2, you're going to love it because it's much simpler. Okay, and I promised you this method yesterday, so let's talk about it. Here's method 2. Remember your quadratic formula. Remember, quadratic formula is if I have ax squared plus bx plus c, don't worry, Fisher, I'm getting there, is equal to 0, then what does x equal?
Negative b plus or minus the square root of b squared minus 4ac over 2a. Let's go.
Negative b plus or minus the square root of b squared minus 4ac over 2a. You got it. It's in your head now. So there is our quadratic formula. This part here, negative b over 2a, this part of the quadratic formula tells you the axis of symmetry. That tells you the x value of your vertex. So just use that. You could use that to solve this question very quickly. And then once you have the x value of your vertex, sub it into the quadratic, and you'll find the y value. Then you can just write it as the vertex form. Jamie? Johnny?
What's that called again? Like that equation?
The negative b over 2a?
Yeah.
Oh, this equation up here?
Yeah.
This equation is a quadratic formula.
For what?
It solves this equation. If I have some quadratic, ax squared plus bx plus c equals 0, then x will be given by these. Okay. And let's write the 2a a little nicer. That's 2a. Yeah. So what that's telling me, Johnny, is if I have a quadratic, it will give me these x values.
Okay.
The values where the x-intercepts, the zeros, the solutions, the roots, right? The quadratic formula gives us the roots. So the negative b over 2a, that's the equation of the axis of symmetry. The vertex always lies on the axis of symmetry. So if you know the x value of the vertex, you can just substitute that in here and solve for the y value of the vertex. Then you have the vertex. You could even write it in vertex form with never having completed the square. Okay, so that's just another way to do it. Now here, if we did this, let's do the negative b over 2a to get to a solution of this question. So here, negative b over 2a, here's my negative b, here's my a. So negative b over 2a in this case would equal negative b, this is negative 20. So actually I have positive 20 because that's negative 20, positive 20. Okay? That's negative b over 2a. 2 times 20 is 40. Look at how fast that is to solve this question. There. Set your temperature at 1/2 degree, and that's going to give you the lowest concentration of bacteria. Pretty easy, eh?
No, the other one's easier. It is.
Completing the square?
This is completely. And I actually enjoy doing that one. I didn't enjoy doing that.
I already feel so
Plus,
confused.
this makes.
You're so confused?
Well, I understand.
Okay, I'll talk more about it and then the confusion will dissipate. So we've got some practice problems there, but here, let's carry on with some more optimization problems. We want to be able to now not only be given an equation and solve for the vertex like I just showed you, but also generate our own equations with a variety of situations that create quadratics. So let's take a look at those. Optimization, it means to find out the value that's the maximum or the minimum of some equation. In the case of quadratics, those are always vertexes, because those are the only points that turn around that could possibly be a maximum or could possibly be a minimum. So the first thing that you're going to do when you're solving some of these problems, always draw a diagram or get a really strong visualization of what you're looking at. Start with that. I might visualize in my head, but I'll always be able to show you with a diagram. The more diagrams you draw, the quicker you'll be able to visualize in your head. That can help you in art. That can help you in imagining how you're going to get a puck through 3 defenders to the other guy. But of course, you need that skill to be instantaneous if you're going to apply it in sports. But I do believe you can develop it by working on your math or playing a lot of asteroids. Okay, next, you need let statements after that. After you draw this diagram, use let statements to identify your variables x and y. And then create an equation that represents the situation. This is the tricky part, and we're going to be looking through the words in the problem to create these types of things. And then once you find the x and y values of the vertex, you are going to use those values to interpret your answer. This is another reason why it's important to use let statements, because when you say something like let x equal time, or let y equal the width, or something like that, and you get a vertex and it tells you x is 10, you know that's 10 seconds. You know 10 seconds will be the optimal time. If you get a y value of like 10, that's 10 meters, you know that the optimal y value is 10 meters. Okay? So your let statements help you interpret what the vertex means. So let's take a look here. If Kathy has 48 meters of fencing and she needs to make a rectangular pen for her pet, what's the maximum area? Okay. So we're going to start with the diagram, right? Tells me to make a rectangular pen. So here's a rectangle. And the rectangle will have some length and some width. Can I create an equation that relates length to width? Length and width. Well, area is going to be what I want, right? That's what I'm maximizing. I want to maximize area. So the area of this rectangle is equal to length times width. But that's one equation with 2 variables, and I don't know what to do with that, to be honest. But if I can express length as a function of width, then I can make some progress on this equation. What's the total perimeter of my rectangular pen? 48. What's another way to say 48 in this situation? Here, I'll give you a hint. That's the length over there, and that's the width over there as well. 48 equals, because it told me to make a rectangular pen. If I could make a circular pen, I could cover more area.
No.
Wait, are all of them the same size?
Huh?
Are all of them the same length?
Is the length necessarily the length of a width in a rectangle? No. And that's what we're going to be able to change. We could make the width all the way down to 0 or the width all the way up to 14. Right? There's so many different rectangles that we can make, and we want to find the one that has the optimal area. So actually finding an equation helps us do that. So let's do that. Sorry?
Are we talking about like length times width equals 48? So
No, we have 48 meters of fencing. So this plus this plus this plus this is 48. Aha, I just did it. I was just trying to get from you guys. But anyway, here we go. 48 equals 2L plus 2W. People see it? Yeah. See, 2 times the length plus 2 times the width is going to be the perimeter of a rectangle. And we know that. The perimeter of the thing is just the sum of all the sides. That's the fencing that's going to go around this area. So I want to write down what I know and work towards what I don't know, which is what's the optimal dimensions. It's going to be a square, but we're going to prove it by doing this. So here, Next, to simplify this, what I'd like is to express one of length or width as an expression of the other one. So here, I'm going to divide the whole equation by 2. So let me move it up a little bit. I'm going to divide the whole equation by 2, so I get 24 equals L plus W. Does that make sense? Divide whole equation by 2. And then I'm going to subtract W from one of the sides, so that I have 24 minus W equals L. Aha! Now I can substitute this in here. Now I will have one equation, one unknown. It will be solvable. Let's take a look. Area of the rectangle is going to be equal to not length times width. Well, it is, but another way of saying length is 24 minus W. 24 minus W times W. Okay? Now that is going to make what kind of shape when I graph it? Oh, yeah, very good. Because you see that the W is multiplying the W here. So that's great. So we're going to create a parabola. Let's make our parabola, and then you guys want to complete the square? Or you want to do a different way to solve this one? Maximize area.
Complete the square.
Complete the square. Okay, let's stay with complete the square. The area of this rectangle is given by the parabola negative W squared, because that's negative W times W, and then 24 times W. So plus 24W. Notice that my A is negative. That means it's a parabola opening down, and it has a maximum. That should make sense, because there's some values where we can get a 0 area. If our length is 24, then our width would be 0, and then we'd have 24 times 0 would be our area. So that's one of the zeros. The other 0 happens when the width is 24 and the length is 0. That's another 0. The midpoint is our maximum. So let's complete the square on this guy, because that's the method y'all want to use. That's fine. It's a good method. So here, the area of the rectangle is equal to, my first step is to factor out that A. So I'm going to have negative 1 multiplied by W squared minus 24W. And then I'm going to take half of that and square it. So notice that this flipped signs when I factored out the negative 1. Don't make the mistake of forgetting to flip a sign, because that's a common error. Okay? And then I'm going to take negative 24, take half of it, and square it. And that's going to give me 144. Because negative 24 over 2 is negative 12. Negative 12 squared is 144. Hooray! My favorite number. So I'm going to add 144 and subtract 144. Okay? Notice I did both of them in the brackets because I have negative 1 of both of those things. Now this here, oh yeah, highlighting doesn't work in this program because reasons. Okay. This here is my perfect square trinomial. Johnny.
Why is it minus 1 there?
Because I always factor out A. And A here, see A?
Yeah.
It's okay. 1. It's negative 1.
Okay, yeah.
So I want to factor that out to get this right. Otherwise, I'll be making mistakes. So I factor that out of this and this. That's why this sign flipped as well. Okay. So now I factor this. A of the rectangle is equal to negative W minus 12 squared. And then this is going to come outside of the equation, but I have to multiply it by negative 1. So it's going to be plus 144. So this gives me a parabola. Okay. It has a 0 at 0 and a 0 at 24. The maximum is at 12. Okay, and it looks something like this. This is an equation for the possible areas, and this is at 144. Notice that the output, the y value of the vertex, this is the point 12, 144. Okay, if that's 12, 144, see, because this is a sign flipper, the negative 12 sign flipper, so it's positive 12 is the location of the vertex. The y value is 144. So what's the area of the pen? I have 48 meters of fencing. The width is 12. The length is 12. The area is 144. notice that it's not only telling me what value should I make the W to maximize this, but it's also telling me when you maximize it, this is going to be the area. So that's one of the advantages of completing the square. We get all the information in one go. Okay?
Just a quick question. What happens with the minus 44 there? Like, why don't you use
Oh, the minus 44? So when I take that outside the brackets, Johnny, this is a great question. When I take that out of the brackets, I have to remember to multiply it by this.
Right.
So that comes out and becomes plus 144.
Okay. That makes sense.
Hooray! So I just want to just review, because this is like one of those, like, take an easier example and understand it fully to then work on harder examples. We first had to draw a picture of this rectangular pen. We labeled our sides. Let the width be W. Let the length be L. And then we said, well, I don't know what L and W, their relationship is, but I do know that the perimeter is 48. So let's write an expression for the perimeter. And then we solved that expression for one of the variables so that we could put that into another equation and create a quadratic. Once we have a quadratic, we'll have a parabola that will have a maximum somewhere. We can find that. We can do things with that value. Now she knows actually the optimum value for any rectangle, if you want to maximize area, is a square. We just proved it. Now, that might feel like, well, you should just know that it's just a square always and just it be a square. But what if we had the same amount of fencing, but we had a wall here? And we can use the wall for one of the sides as like an infinite just freebie. We don't have to spend fencing on that. This is a different question. I'll do it quickly up here. Here I have my width and my length, okay? So I expect my length is going to be longer than my width in this case, because now I'm maximizing this area, which is still length times width, but now my equation for the perimeter looks like this. 48 is equal to L plus 2W, because I get to use the side of the building. Do people kind of intuitively feel like I want to use as much of the building as possible while still maximizing the area? So this is actually not going to be a square anymore. It's going to stretch out and be a rectangle. You feel that?
Yeah.
Okay, so let's see what dimensions the rectangle are. Do you think it's going to be like 2 to 1? Or maybe 1.5 to 1? Guess, what do you think the ratio of the sides is going to be? Just make a guess. Make a guess for yourself, and then we'll keep going. Okay, I'm just going to move my diagram down so that I can do more mathy stuff here. Here's my diagram. Here's my width. Here's my length. W, length. Okay, so there's my equation for the sides. So L is equal to 48 minus 2W. And there's what I'm going to put into my length times width formula. Area of the rectangle is now equal to length multiplied by width. But instead of writing length, I'm going to write this. So 48 minus 2W, that's the length. I'm going to multiply that by the width, W. Now it creates a quadratic, negative 2W squared plus 48W. Complete the square, sure. Factor out the negative 2. Negative 2W squared minus 24W. Okay? Cool. Interesting. All right, and now I take half of that and square it, so it's still 144 that I'm using. Okay? So I'm going to add 144 and subtract 144. Did I do something wrong? Length times width is my length. Length plus 2 times the width is 48. Yeah. Okay. And then here, I'm going to optimize that. It's still 12. Why is it still 12? Have I made a mistake somewhere? Must be. Because it's not. Oh, it is. It is still 12. Huh, it's still 12. The width is still 12, but the length is now 24. So this is equal to negative 2 times W minus 12 squared. Here's my perfect square trinomial right there. W minus 12 squared. And then this comes out and gets multiplied by the -2, so that's positive 288. So in this situation, the length is double the width. It's no longer a square. This is 24 long. This is 12 long. So we have the same width, optimizing the area here. And it's a rectangle that's ratio 2 to 1. And the area that we can achieve is now 288. So we doubled the possible area by using some unlimited wall that we can create a rectangular pen with.
Well, what's this called? It's like getting the perfect square or whatever.
This one here?
Yeah.
Yeah, this is still using complete the square method.
Oh, but it's just a different.
It's a different case because now I have a wall that I can use. So I have WWL, but only one L. This is a wall.
So is this just like hypothetical? If that was the
Yeah,
question?
I made a new question.
Okay, cool.
Yeah, and this is the wall of the house, or like the wall of the gymnasium. It's as long as you'd ever want. You can use it as one of your sides. You only have to fence in 3 sides. We can double our area in that case.
I just want to make sure it wasn't like a second step to that one.
No, it's the only extra step here is that I had to factor out a 2, whereas here I had to factor out a -1.
Right.
Okay. So let's keep going. Here we go. The summer theater charges $10 per ticket, and it has a full house of 500 nightly. The manager thinks that if we increase the ticket sales by $2, they'll lose 50 people in their audience. So now we want to maximize the revenue for this type of situation. I think this will be the last question that we look at, and then we'll start working independently. So here, what I want to do here is a diagram's not really going to help me, but what I want to think about is how do they make money? They make money when a certain number of people buy a ticket at a certain price. There's going to be a function for the price of the ticket. There's going to be a function for the number of tickets. I multiply those 2 functions together, and I'll get a parabola. Okay? So if we have, and so to do these ones, you're going to say, right, so we're going to let x equal the number of price increases. So we have one equation, which is the cost. So we're going to call this y. This is the y, but it's cost. So I'm going to say c here. Y is the cost function is equal to, we would sell 500 with 0 increases. So I'm going to put that over here. And I'm going to add on the number of people we lose for every increase. So we're going to have a -50 people for every x. -50x plus 500. This is an example of a line. Y equals m times x plus b. My initial value is b. It's there 500. So that's my initial number of tickets I would sell if I don't change the price, if x is 0. Every time I increase the price by $2, that's x going to 1, then I lose 50 people. So that's how I've set that one up. And now I want to know how much money are they making? They make money. So we want to take a look now, have an equation that shows how much money they make per ticket. So here is the y, and this is p for price. The equation here would be, we start at $10. That's our initial value. And we're going to add $2 for every x value. Every time we increase the price, the cost of the ticket goes up by $2. So this gives us our 2 lines that we're going to multiply together. So now I have a profit function. Profit is going to equal the cost multiplied by the number sold. So this is cost here. This is number sold. So if I write that out, P is going to equal -50 times x plus 500. Okay? And then I'm going to multiply that by 2x plus 10. Now I get an equation in factored form. So in this case, I could factor both of these, find when these are zeros, and find the midpoint between the zeros to find the number of price increases that will give me the best price. That would be the method that I would use, but you want me to complete the square, don't you, Hannah?
Yeah.
Yeah, okay, so I better complete the square, make Hannah happy. here we go. I need to first convert this to an equation in standard form, then I can complete the square, because I can't complete the square from factored form. So I'm going to multiply these out. I have to apply my FOIL rule. And here I'm going to multiply this by this, this by this, this by this, and this by this. So let's do that. I'm going to have here negative 50x times 2x. That will be negative 100x squared. Negative 50x times 10, that will be minus 500x. 500 times 2x, that would be 1000x. So it's going to be plus 1000x. And then 500 times 10, that will be plus 5,000. So this gives me an equation in standard form that looks like this. The profit is equal to negative 100 times x squared minus 5 plus 500x plus 5,000. This tells me it's a quadratic that opens downwards. It's very slopey, extremely slopey. It has a value of negative 100. So I get that from the A. It's crossing at a positive slope with a slope 500. So its vertex is going to be in positive values of x. It's going to be higher than its y-intercept. And the y-intercept is $5,000. What that's telling me is if they charge $10, the initial price, the zero price increases, if they don't change the price, they have applied zero price increases, their profit is $5,000. Let's see if that makes sense. They're charging $10 per ticket and they sell 500 tickets nightly. That makes sense. Okay, let's sell fewer tickets but make more money. So that's going to mean increase the price to find that vertex. So we can find that vertex by completing the square here. So if I complete the square, my first step is to write out this function, but with the a factored out of these two values. So that's going to be this. Okay, now I complete the square. I've got a b value that's negative 5, so that's going to create some fractions. So here we go. Let's complete the square. First, I'm going to take negative 5, divide it by 2, and square it. That's going to give me 25 over 4. So I multiply top times top. Negative 5 times negative 5 is positive 25. Bottom times bottom. 2 times 2 is 4. Fractions are lovely. Yeah. P is equal to negative 100 times x squared minus 5x plus 25 over 4 minus 25 over 4 plus 5,000.
Is this like the best way to do it?
I would have done it a different way. But this way, the advantage of this way, Alex, is it's going to tell you right away not only how many increases to make to your price, but what your profit will be at that time. So it gives you your X and your Y simultaneously. Dun, 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 dun. Yeah. So here I have my perfect square trinomial right there. So let's write that as a perfect square. P equals negative 100 times X minus 5 over 2. So there's the number of price increases I should have. 2.5 price increases. I should increase the price by $5. Squared. And then this number has to multiply that number to come outside the bracket. This one multiplies this when it comes out of the bracket. So that's negative 25 times negative 100 over 4. So maybe I work that out over here. Negative 100, rather than do it in my head and lose all of you. Negative 100 times negative 25 over 4. Well, I can cancel the 4 in there and make that 25 and cancel this 4. Because 100 divided by 4 is 25. So this is just negative 25 squared, which equals 625. Your calculator will tell you the same thing. Yeah?
Sorry, when you got the minus 5 over 2 fraction, did you get that from minus 5 divided by like just 2?
Oh, so the way we create that complete the square Jerry Maguire number is we look at this number here, we divide it by 2 and square it. And that tells me this number, what I need to add
Yeah.
and subtract.
Okay, that's what I thought.
Can I get my pen?
Yeah, of course. Yeah. And so this is the increase in profit. That's the increase in profit that we can make if we increase the price per ticket by $5. You will make an extra, even though you will sell fewer tickets, you will make $625 more doing it that way. And your maximum profit goes from $5,000 to $5,625. They should increase the price and you always finish with a therefore statement, right? They should increase the price 5/2 times or add $5 to the ticket cost. And their profit will be $5,625. So you want this type of let statement at the end because it shows people you understand what you just found, and it also tells yourself, I just understand what I found. Also, we're doing application questions today, so you want this to feel real to your brain. You want to know that there's people out there right now making more money because they can do math like this. $600 is a lot of money. So maybe that means that they can take another extra month of vacation or something. Okay, so lots of things to practice, and that gives me a lot of chances to come around and visit you and help you with your questions, which I am sure will be many, and I will be delighted to help you with those. For those that need to write the quiz today, we should do that immediately after break. Would be a good time to start that.
Can we start it now?
Immediately after break, start some of these practice problems. Try some applications first. Get stuck on the applications now, and then I can help you, and then you can try the quiz.
I'm just super